Hello, my name is Ye-Chun Kim, and I'm currently working as a data engineer in South Korea and pursuing a second bachelor's degree in computer science. As someone who works closely with data pipelines and model deployments, I've always had a strong interest in classical machine learning algorithms, not just in theory, but in how they are implemented and applied in practice. For this assignment, I chose the Fork Commit Merge open source project, which stood out to me as an educational platform specifically built to help developers practice Git workflows and contribute code in a structured environment. I selected an issue involving the implementation of decision tree classifier from scratch. Since I already had some familiarity with this model from both work and study, it was the perfect opportunity to go deeper into its inner workings, such as recursive splitting and Gini index calculations. Uh, this is an open source project designed for learning and contribution. It provides over 130 issues in various difficulties and programming languages. So contributors get to practice real-world Git workflows, such as forking, committing, and submitting pull requests. A unique aspect is that each merged pull request is automatically reverted, allowing multiple contributors to learn from the same task. As you can see, it has active community with many forks and issues. The contributing main file provides clear instruction on forking the repository, creating branch, and submitting pull request. I initially selected issue 3023, which was later closed and reissued as 3380 with the exact same contents. So I confirmed with the TA that I could proceed using the new issue. The task required implementing a basic decision tree classifier in Python from scratch. Yeah. In my implementation, I created two main classes. First one is tree node. This represent each node in the tree, either of decision nodes or leaf nodes containing the output label. And second one is simple decision tree. This handles the training and prediction process. This have four methods, and the first one is fit method. This builds the decision tree recursively, and build to tree selects. Second method selects the best feature and split using the Gini index. And yeah, and I also created a utility function like divided on feature. This split data based on feature value, and calc Gini calculates Gini impurity for splits. And last one is votes, performs majority voting at leaf nodes. At the end, I included a main section with the test data set that demonstrate how the tree makes prediction. Contributing to this project helped me reapply core Git workflows. Although I'm already working as a developer, this structured open source experience helped me reinforce best practices like following templates and writing testable codes. Unexpected challenge was that my originally approved issue was closed. Since I had already finished the implementation, I conformed with my TA and submitted the solution under the reissued issue. This taught me how important it is to communicate early and adapt quickly in community-driven projects. So thanks to the folks and commit merge maintainers for building such a practical and educational platform. Clear contribution guidelines make it easy to stay focused and learning effectively. And I'm also grateful to my TA for helping me resolve the issue closer smoothly. This project reaffirmed the value of open source, not just for coding, but for growing through collaboration. Thank you.